So, good evening, all. Welcome back for the second day of this workshop on network pharmacology. And in addition to the network pharmacology, we have also include in silico or molecular docking studies. So today, Harshad is going to talk about the molecular docking studies of the targets which we have identified yesterday. Amruta has shown and she has gone through the process. So, Harshad will start with the molecular docking with the presentation and with the hands-on demo of the tools which he have prepared. Over to you, Harshad.
Thank you, sir. Uh, so today I will be good evening, everyone. So today I will be discussing about molecular docking. Uh, Firstly, I will present some introductory part and then start the demo. So in the introduction, the molecular docking is a computational method used to predict the preferred orientation of one molecule, which is a ligand, to another receptor when they form a bond with the target.
Harshad, your voice is breaking. Hello, Harshad. Okay, I think he got some issue with his connectivity. So he will be back.
Hello, sir.
Yeah, hello, Arshad.
Hello, sir. I think there was some issue. Actually, I was
Yeah,
presenting and I just.
it got disconnected. No problem. You can start again.
Okay, I will start. Sorry, sir.
Yes.
Is it visible? I'm just present.
Not yet. Not yet.
Now it is visible.
Yeah. Yes. The presentation is not visible, but your screen is
Okay.
visible now. Yeah.
Okay. Sorry for the inconvenience. Actually, it was. Okay. Good evening, everyone. So I am Arshad Pisar. So today I will be discussing the molecular docking, uh, continuation to the network pharmacology. Now we will be seeing the demonstration of molecular docking. I will give the quick introduction to the various steps involved in the docking and introduction to docking, and then start the demonstration. So, in the introduction, what is molecular docking? It is a computational method used to predict the preferred orientation of one molecule, a ligand to another receptor when they form a stable complex. It mimics the process of ligand binding to a protein target. Uh, the molecular docking is actually used to accelerate the discovery process, reduce costs associated with the experimental screening, provides insights to the protein ligand interaction. So we can actually in the processes or in the drug discovery, like lead identification, lead optimization, then target identification and target optimization, we can use this uh, computational method. uh, then these are the key steps. The first step is the target preparation. To prepare a target, we need to uh, isolate or extract the target. For this we use the Protein Data Bank database. This is the well-known database for the protein, 3D protein structures. The data from the PDB comes from the X-ray crystallography, nuclear magnetic resonance, and the cryo-electron microscopy. Uh, Firstly, we curate the protein. Firstly, we extract the protein from the PDB database. Then the further step is to clean the macromolecule. And the cleaning includes the removal of heat atoms, the water molecules, and the ligand groups from the macromolecule, where we can get a pure form of macromolecule which is ready to dock. Then after the macromolecule preparation, uh, there is another next step is to ligand preparation. For that purpose, we use the PubChem database. So the PubChem is a public chemical database. It's a massive collection of chemical substances and their biological activities, which is actually developed by National Institute of Health, specifically by the National Center for Biotechnology Information, NCBI. To obtain the 3D structures of the ligands, we use the database. For the structures which are not available on this database, there are other databases, or the structures which are not published in the public domain. We can use the 3D structure drawing tools like ChemDraw and Marvin Sketch.js, where we can obtain the SDF files for the ligand preparation. We will discuss that in further demonstration. Then the next step is to docking. For the docking, today we will be using the Pyrex software tool for the molecular docking. Uh, Pyrex is a powerful open source software tool designed for virtual screening in computational drug discovery. Uh, the Pyrex facilitates the entire virtual screening process from data preparation to result analysis. The Pyrex tool uses the docking engines like Autodoc Vina. Other than Pyrex, we can use Amdoc, Autodoc Vina in separate for docking purpose. The reason to use the Pyrex that it provides the uh, multi-component docking, and also it's a open source platform. So we will be learning this software today for the docking. And for the visualization of the docking, the compound, the macromolecule and ligand which we docked for previously on the Pyrex software, we will be visualizing that molecular interaction in Discovery Bio software. So it's a powerful suite of software tools for molecular modeling, simulation, and data analysis. It's widely used in drug discovery and other areas of life sciences research. The Discovery Studio provides the 3D visualization of software. Also, it also provides the 2D schematic representation for our docking molecular interaction, which which gives us uh, different analysis, interaction analysis. Like we can analyze the types of bonds, hydrophobic contacts, hydrogen bonds, and also it will show what type of interaction is happening in the molecular. Okay, so this was the introductory part. Now we will delve into the demonstration of the docking. So for the first step is the ligand preparation. For that, I will be using the PubChem database. So we will take routine as an example for our ligand. So this is the interface of software. I have searched, I have entered the search term as routine, and now there are different structures visible for the routine. So I will use first one. From here, I am going to download the 3D structure for our ligand, which will be SDF file, which is structured data file format. We need to download in SDF file, which will be converted into PDBQT, which is the format required for the Autodoc Vina. So this is our compound. Now we'll load this compound in Pyrex. So this is the interface of software. And these are the different options. We will be using the Vina wizard for that purpose. Now to load the compound, we will be using the OpenBabel. This OpenBabel is inbuilt in this Pyrex software. This tool converts the SDF format into PDBQT, which will be required for the docking. So from here, insert new item. I will be adding my compound. So I already downloaded that. So this is our structure which we downloaded from PubChem database. So this is our structure. First, we need to minimize the torsion energy for the compound. For that, we have to right click on the structure, and then option, the minimize selected option we have to choose, which will minimize the energy, torsion energy of the compound, which will minimize the errors happening while the docking. Now we need to convert it into PDBQT. So is the option convert selected to Autodoc ligand PDBQT. We have to select that one. So here is our compound. I will remove the old cliche from the software. So I will remove the old cliche. Convert all to selected to ligand order. So here is our compound. So our ligand is prepared for docking. Now in the second step, I will be preparing the target. For the target preparation, I will go on the PDB database as we discussed previously, protein database. So this is interface of the software. Here we have to enter the search term. We can enter the unique IDs for the protein or the name of the protein. If I select here AKT1, for example, or protein, we'll be doing docking on this protein. So this is, you can apply the filters here, Homo sapiens. You want, you can apply experimental method. Here are filters you can apply to sort out the structure which you want to download for the, yeah. For example, if you select this protein and download file option, you need to download it from in the PDB format here. So here is the structure will get downloaded. The structure. Now this was part to extract the protein. Now for the cleaning of protein, you'll be using the Discover Studio Bio software. So I have the protein which I will open this protein. We need to clean this protein, which actually already clean protein. I will open the recent one and show the how cleaning is performed. So this one, you can see the water molecules, the ligand groups already there. We need to clean these groups. For that purpose, you need to go in the control edge in the hierarchy. You can go from here also. Here you have to select the het atom, the water molecules, the ligand groups. We will remove these unwanted groups from the structure. Here is cut option. You need to click on Control X. Now our protein is ready to install in the Pyrex software. To upload protein, go in the files, then load molecule. You have to go in the load molecule, install this protein in the. So this is our protein, which you downloaded from PDP and cleaned in the Discovery Bio Studio. So these are the amino acids you can see. I have to convert this in the make macromolecule, which will convert this protein in PDBQT format, which is required for Autodoc Vina. So here right click on the in the molecule tab, right click on the protein, then go in the Autodoc, then make macromolecule option you have to click. The Autodoc protein is ready for docking. So you have to go to the Vina Visa tab in the controls, then in the select molecules you have to select these two molecules like this. You can select. Now here you can see one ligand is selected and also our protein is also selected here. So I will select the run Vina option. After loading molecule, you have to apply grid where uh, you have to define the binding site of the protein. For that purpose, if you know the binding site on the protein, you can select that from molecules where you can do the toggle selection. Here the option toggle selection spheres, where for example, if our protein has this four, it's ALA5, ILE6, and well, so for example, if we consider this as a binding site of our protein, you can select in the toggle. You can select this site. Now you can visualize the pink colored dot spheres, which is our binding side, which we just highlighted. Now you can apply grid on this side. You may have to make sure that your grid is sufficient size that the ligand must be docked there. So based on that, you have to optimize the size of the grid. Like this, you can apply the grid on the binding side. So we are doing this for the demonstration purpose. So I will select whole protein as our binding side. So I will select the whole protein, so maximize option, and we will dock the whole protein. So you have to click on the run win option here. Now this docking is under process. I think there was some issue with. There is issue in the software. I will reperform the docking. Yeah, so docking was done actually. So these are the binding affinity, which is measured in kilocal per mole. This actually indicates the binding energy of the, which is also known as the Gibbs free energy. The lesser the value of this binding affinity is, the higher the binding affinity, which indicates the higher the binding affinity. So we can see the minus 11.9 is our binding affinity on the RMSD one. So RMSD, the root mean square deviation, which is a mathematical term used to denote different conformers actually, which are which is calculated based on the bond lengths of the conformer. So the compound with highest, the conformer with highest binding affinity uh, is denoted as 0, which is considered as a reference, and based on that reference, compared to that reference, other conformers are given the values of RMSD. So minus 11.9, we can consider this as our docking score, binding affinity of our compound, which we perform a routine and AKT one. So now we will see the visualization. For the visualization, we need to con- uh, convert the these PDBQT files. These are the files which is created for the docking. We have to convert this in PDB, which will be visualized in the Discovery Bio Studio. For the visualization, we can also use PyMol, which actually utilizes the PDB Qt format. For the Discovery Studio, we need to take in PDB format. So we'll extract this interaction. Save as PDB option is here. So I will save it in our workspace. We also have to take this protein and go it. And so the work in the Pyrex is done. Now we'll go to the Discovery Bio software, where we'll visualize our docking molecular interaction. So I'll open our file which we extracted. So this was our file. This protein. We'll first open the protein structure. So this is the protein structure. In the same workspace, we will upload the interaction, which will be orientation of our conformer. This is conformer. Now I'm going to paste this. You have to select this compound. So Control C, copy this and paste it in the protein file. So I have now pasted the protein file. Now we can visualize the interaction in 3D space. I will make the background white. Okay, so we can clearly see the ligand and protein group in the 3D space. So to visualize the ligand interaction, there is toolbar where is defined receptor, in there is protein, and in the ligand you can select this ligand group. Control H. This is our ligand group. Now we will go in the ligand interaction. So it is showing the interacting amino acid residues with the routine. Now we'll see the 2D diagram. Here is option show 2D diagram. We'll click on that option. We can see the 2D diagram for our interaction. This 2D diagram is actually elaborative, which we can clearly see how the molecule is interacting with the amino acid residues, different like aspartate, glycine, threonine. And in the you can see the types of, based on the color codes, we can see what are the types of bonds it is interacting with. Now if we extend this bar, this tool from here, this arrow, you will have a monitor. If we go in the non-bond monitor, we can see the different color codes and the types of interaction. In category, we can see what are the types of interaction happening in the molecular interaction, and from which amino acid group to which compound group, and type of interaction, also angles, bond lengths, we can analyze. For the analysis of a molecular interaction, we can utilize this monitor. From here we can adjust the display style. I want to see We can import this different types of display styles. We want to see our interaction. This was about visualization and analysis of the molecular interaction. We can copy this diagram and save in our workspace where we want to use this. So this was all about the demonstration of molecular docking. So this was all from my side. So I have tried to cover the whole demonstration of how molecular docking works and give the introduction to how docking works in using the Pyrex software and Discovery Bio. We can actually use other softwares like PyMol, and then so that's all from my side.
Thank you, Harshad. If you have any questions, please let me know. Let us know, and Harshad is here to answer. So, Harshad, there is one question
Yes, sir.
from Gauri. She's asking, can you repeat the procedure of Discovery Studio again? So, if you
Yes.
show, yeah, about the protein.
Yeah, yeah, okay. Yeah, definitely I will show that. I'll delete this previous one and show again how to visualize the protein molecular interaction in the discovery bio. Yeah. So you have to just open the protein interaction. So these are two files, which is doc pdb and protein pdb, which we extracted from the Pyrex. So first one, you have to open the protein, and when you open protein, you have to simultaneously, you also have to open the ligand. This doc pdb, this ligand. Now you have to copy the ligand on the PDB protein file. So I will just copy the ligand to the PDB protein file. So now we can see in 3D space. And from the tool, you can, here is the option. I will just make background white. Okay. Now we can clearly see the 3D space for molecular interaction. Now you have to go to the ligand interaction tab. You can see the ligand interactions in 3D space. To visualize in 2D, you have to go on the 2D diagram, where you can see the molecular interaction file, molecular interaction in 2D, where you can understand the molecular docking interactions. Mm, From here, you can open the monitor. In non-bound monitor, you have to open. You can see the types of interactions. It will give in detail information about how the molecule is interacting with the protein, types of bonds, what is the chemistry of bond, then bond angles, bond lengths also for the analysis purpose. And from here, display style, we can select the which display style we want to see. And we can export this image directly by copying the image in this also. So that was the visualization part in the Discovery Studio. Is that clear for? Let me know.
Thank you, Harshad. I hope, Gauri, that you got information about how to utilize the studio, Discovery Studio. So, if there are any more questions, you can let us know here, or you can always comment on the video, and we will get back to you. Okay, I think there are no more questions, Harshad.
Yes.
Yeah, thank you, Harshad, for explaining the molecular docking
Thank you, sir.
with the Pyrex software. As mentioned yesterday, that we are in process where we want to actually utilize both the methodology in the internship manner for UG student, PG student, and also some of the PhD students are also interested in this. So as part of that, and also part of the Solife Industry Connect program, we will be interested to start an internship on this network pharmacology. There is a question from Rohini. She's asking for repeat the pre-docking protein preparation. I think it's the same one,
Okay.
right? Which you done in the discovery, or is different?
No, no, pre-docking protein preparation. She's asking
Yeah,
for
in the
the cleaning,
Pyrex.
I think.
Okay, okay,
The cleaning of protein which we done. Actually.
okay. So can you repeat it?
Sure, I will. Sure, I will show that again. Actually. So I have to download the structure from the PDB database. So I will go through the PDB database. So I will, for example, we'll download the structure. Download files. You have to download the structure in PDB format. So this is our structure. We will open the structure, which will directly open Discord Studio. Now, show display style. I will make the background white to clear visibility. Okay. Now you can see the water molecules and the ligand groups in the protein structure. We have to clean that in this. So we have to go to the hierarchy. So for that, Control H. You can see this tab for the hierarchy. You have to select the unwanted groups like het atoms. If you select het atom, everything will be selected other than macromolecule, where you can select water and ligand groups which you do not wanted in this structure. So then you have to cut. Or you can this control X function. You can use the control X function. Now you can see our protein is cleaned, which will be ready for docking. You have to save this file in PDB format and open the Pyrex software. So that was about the pre-doc procedure to clean the protein. I think you understood that.
Okay, thank you, Harshad.
Thank you, sir.
So I hope that all the questions and all the queries have been resolved. So if there are anything, as I said, that you can comment or you can contact. So thank you for joining, and we are planning for weekend workshops of this network pharmacology, and simultaneously an internship for UG, PG, and PhD students. So if there are students who are interested, do let us know. Thank you, Harshad.
Thank you,
Thank you
sir.
for joining.
Thank you.